Okay, welcome to Let's Get to the Marks. I'm going to go through one of the core practicals for GCSE Physics in the AQA specification. This is both for separate science and for combined science. So let's get into it. Okay, question two. Figure three shows the equipment used. Let's read that again properly. Figure three shows the equipment a teacher used to determine the speed of a water wave. The equipment includes a ripple tank filled with water, a wooden bar that creates ripples on the surface of the water, a light source which causes a shadow of the ripples on the screen. The screen's down here, so we get shadows down there. Here's figure three. You've got a support, you've got the wooden bar that slaps down on the water, creating these ripples, a light that then shines down and creates shadows underneath. You can put a massive piece of paper down here for that. This is the distance. And you got water in there, lovely jubbly. 2.1, describe how equipment in figure three can be used to measure the wavelength, the frequency, and speed of a water wave. 6 marks. So the way this question is structured is you're going to get a couple of marks for describing how you'd use this equipment if you had to work out the wavelength, a couple of marks for describing, imagine how to use this equipment to work out the frequency, and then how would you alter your experiment to work out the speed of a wave. So I'm going to go through it. We want to cover all three aspects there. How would you work out the wavelength? How would you work out the frequency? How would you work out the speed? And it's worth 6 marks. Why don't you get yourself a pen, get yourself a piece of paper, have a go and see if you could bullet point down at least 2 or 3 bullet points for each one. Pause the video, have a go. Right, I'm going to go through the answers. Okay, so this is the equation you're going to need. It's wave speed is equal to frequency times the wavelength. Wave speed is measured in meters per second. Frequency is measured in hertz. A wavelength is measured in meters. Okay, let's go. Okay, this question is slightly different than the normal ripple tank experiments because in this one it's saying, how would you use this equipment to calculate wavelength, frequency, and the speed of a water wave? So we've got to explain all of them. Often they'll say, use this equipment to calculate, say, wave speed. In that situation, you can just say, use this equation, find the frequency from the signal generator. Now, the signal generator is essentially a little machine, and this is going to be connected to the paddle and is what's going to make that vibrate up and down at a certain frequency. So this will decide your frequency, and this is called the signal generator. In the situation where they say, how would you calculate frequency, you can't just for 6 marks say, yeah, look at the signal generator. But if they've asked you to calculate wave speed, you can say, well, find the frequency from the signal generator because you will set it yourself, whatever frequency you choose, and then go into an in-depth discussion of how to just find an accurate wavelength. And then you would say, use the equation to times the frequency from the signal generator by the wavelength to get the wave speed. And vice versa. If they ask you to find the wavelength, you would do an explanation of how to find the wave speed and say divide it by the signal frequency to get the wavelength. So you can always rearrange this equation. But this question is specifically saying how would we use the equipment in each circumstance to find that, and that. So let's get on and explain that. I'm going to start with the frequency. So with the frequency, what we want to do is say mark the screen in a specific place. So what you're going to do, you're going to place a mark on the screen in a specific place. So like you might mark over here on the screen. Let's just show you what I'm actually banging on about. So we might mark there on the screen, and that is my specific mark. Okay. And then what I want to do is count the number of waves. So I'm going to say count the number of waves. Now, you could say wave fronts. You see these black lines here. These are called wave fronts. So each one of these lines here, these black lines that you see going down here, I'm going to get rid of those pink lines, but you see what I'm saying? They are wave fronts. So count the number of wave fronts that pass the marker, that pass the marker every over a specific time period. Now, you're not going to be able to do it per second, or you shouldn't do it per second. Pass that marker over a time period. So what do we mean by that? E.g., I'm going to give you an example. The number of wave fronts that pass in 10 seconds. So why do we want to not do it per second? It's pretty hard to count over 1 second. It's much easier to count the number over 10 seconds. So find, whoa, oh my gosh, I can't type, got butt fingers. Find the time period by dividing the time by number of waves. And so what you're going to do, the time was 10 seconds. So 10 seconds divided by 5 waves. Let's say 5 waves passed over 10 seconds, right? And that's going to mean that our time period is 10 divided by 5. That is 2 is our
capital T time period, right? Now we can use this equation. 1 over F is equal to, 1 over T, 1 over F is equal to the time period, but I can do 1 over T equals F as well. So I now just go 1 divided by 2, and that's going to give me 0.5 hertz. So that's one way to find the frequency. Of course, you can just look at the signal generator, but I'm going to score a lot more marks. I'm covering a lot more stuff like that. So that would find me the frequency. So count the number of wavefronts that pass a specific mark point over a specific set of time, like 10 seconds, 30 seconds. And then really you can just divide the wavefronts by the time, and that would give you the frequency. That's one way. Or you can do it this long way where you use 1 over T equals F. And so you can do the number of seconds divided by the waves, and then do 1 divided by T, which is the time period, and you'll get the frequency. And there we go. We calculate the frequency. Now we want to put a little bit of an explanation how to find, say, the wavelength over here. So let me go through that next. So what are you going to do here? What you're going to do is you're going to get a meter ruler, and you're going to put the meter ruler alongside. Now, what you've got to make sure is that it is totally flat and it's not diagonal. Otherwise, it's not going to be very accurate. Beware, they might give you a situation where the student hasn't put the ruler straight. If the ruler's not straight, you're not going to measure the correct distance. So you would put your meter ruler alongside the screen or the piece of paper underneath. So this is my meter ruler, and make sure it's straight and it's alongside the screen. So what I'm going to do to calculate wavelength, what do we want to do? We want to say, put a ruler straight alongside or horizontal to the screen. Now we're referring to it as the screen. Remember, I said you can just call it the paper. Take a photo. Now, what with? With a camera. Who's got a camera on them nowadays? Really, I'm just going to say with a mobile phone. And then, as you know, you can pinch and zoom in, right? So take a photo with a mobile phone and then use the zoom to enlarge. And now you're going to be able to read. This is going to make it much more accurate, much more easy to read the distances when you enlarge it. And then you can actually see what you're doing. Now you're going to count the number of the space between two lines. So if we just look at these first two lines, the space between those is one wavelength. That is one. Oh my days, that is one wavelength, right? WL, I'm just using that. That's one wavelength. So you're going to count the number of wavelengths over the distance. So count the number of wavelengths, count the number of wavelengths over the distance. So what you're doing there is, like, say you might have, imagine, count the number of wavelengths over the distance. So imagine that you had 50 centimeters and then do the distance, distance divided by the number of waves. And that is going to tell us how long each wave is. So let's say it was 50 centimeters long, and we're going to divide that by 10. That means each wave is 5 centimeters. You get the idea, right? Now, you might say, why am I making up these numbers? It doesn't say anything about numbers. This helps me get my head around what you're actually doing, and by showing you. So each wave is 5 centimeters. That's the wavelength. Now, wavelength is in meters, so I would need to convert that to meters. So wavelength, I can't spell. Wavelength is in meters. So we want to then divide by 100 to convert to meters. So actually, we want to do 5 divided by 100. Do you need to put numbers in? No, you can just explain it. Divide it by 100 to turn into meters. And so each wavelength in my example is 0.05 meters. And there you go. You've discovered the wavelength. And actually, this is the mean wavelength. Why is it the mean wavelength? Because you did it from 10. So there we go. Or 5, didn't we? We used 5. So I could have counted 10 waves and the distance for 10 waves. So and we did do 10 waves, so I don't know what I'm banging on about. But so this is a mean wavelength because it's found from 10. So now that is the way to calculate the mean wavelength. What I could add over here on the frequency bit is, as well, it's always good to, if you were asked to calculate the frequency, repeat 3 times and find the mean. It's sometimes good to say remove any anomalous results. So if you got an answer that came up completely different than the other two, you remove that when you find the mean. So and find the mean frequency. So you might want to do that and then find the mean frequency. Right, now what we're going to do is, so we've done how to find wave length, and we've done, oh my good gosh. Now personally, if they ask me how would you calculate wave speed, I think that's enough to get 6 marks. And then to just say times the frequency by the wavelength using that, and that's giving you the wave speed. You get 6 marks for that. So if you want to find the wave speed, go frequency times wavelength. That gives you the wave speed, and that would be what I do. But let's say you need to explain exactly how you'd use the equipment to find the wave speed. Well, what do we know about speed? Okay, wave speed, which is given the symbol v for velocity, even though velocity is a vector and speed's a scalar, never mooned. It should be wave velocity, really. But there we go. Let's not get too funky. And we know the equation for speed equals distance divided by time. So, or velocity equals distance divided by time. So really, we just need the distance and the time it takes for a certain wave to cross that distance. So if I switch colors and bust out the green, I might say to calculate the wave speed, I want to do measure a set distance in centimeter and convert to meters. Remember, we need meters for this bad boy. Don't spell meters ER. That's like a gas meter, a measuring instrument, or a voltmeter or an ammeter. When it's distance, it's METRES. Okay, measure a set distance in centimeter and convert to meters. Then time how long it takes a wave front to cross that distance. So this is like a race. Now, um, you could record a video and slow down to get the time more accurately. So often on mobile phones, they'll have time as well, and you could slow that down and record that, and it would be more accurate than trying to do it yourself to actually let the video do it for you, right? So that would be fine. And then that would give you the time, and then just do d over t, and that would give you the wavelength. So measure a distance, convert it to meters, then time how long it takes the wave to cross that distance. You could use a video, blah, 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 and then use this equation to find the speed. So use this equation to find speed. Now, we can always, if you've got a ripple tank 6 marker and it says find the frequency, you can always just explain this method here, how you'd find the wavelength. And then you can say, use the wave speed, find the wave speed, and then rearrange this equation with wave speed over lambda wavelength, and that will give you the frequency. Or so it's totally up to you. Or you could say find the frequency like this. You could do this explanation here to find the frequency. But often you can just find the frequency. It's on the signal blooming generator. So they're much more likely to ask you, how would you calculate the wave speed in water? The water speed or the speed of waves, mechanical waves in water. These are mechanical waves and they're in the water. So they might ask you to find the speed of mechanical waves in the water. And what you could do in that 6 marker is say, look, find the frequency from the signal generator, because you'll set it by this signal generator. So then you don't have to explain all of that. Then what you could say, you could do all of this as your explanation, how to find the wavelength. And then you would say multiply frequency by wavelength to get the wave speed. And that would be fine for 6 marks. So alternatively, if you're feeling like it, you could go into the detail about how you find the frequency, how you find the wavelength, then say multiply together and find the wave speed. I kind of find this method here is a little bit difficult to actually mark. How do you actually mark a wave? These are all shadows on the screen. How do you know which is the shadow you're looking at and that it's crossed the distance? This appears on mark schemes, but I'm not too keen on that method for finding the wave speed. Personally, I find these much more accurate and then just use the equation to rearrange. Anyway, I hope that helps. Sharing's caring. Hit the like, punch up the bell, subscribe. Let's get to the marks.
You're still here? It's over.